Hello everyone, I am Dr. Andrew Shu Lee. Today, we will discuss a topic that challenges traditional views. Did you know? Mild, short-term stress can actually protect our body. Today's focus is remote ischemic conditioning, or RIC for short, a modern approach to wellness medicine. When we encounter stress, the body does not passively endure it. Rather, it activates a series of defensive mechanisms. First, there is the acute stress response. Activation of the sympathetic nervous system causes a surge in adrenaline and cortisol secretion, which increases heart rate, raises blood pressure, and boosts glucose supply, helping us rapidly respond to threats. Next is autophagy. Cells remove damaged proteins and aging organelles to maintain stability and health. Stress can also temporarily boost immune function by enhancing the activity of natural killer cells, thereby strengthening the body's defenses. Simultaneously, the body activates the antioxidant system, utilizing enzymes such as SO, D, catalase, and glutathione peroxidase to neutralize free radicals and prevent cellular damage. Short-term stress also induces anti-inflammatory effects, suppressing excessive immune responses to protect the body from inflammation-related injury. Finally, there is the anti-apoptotic mechanism. Stress triggers cell survival signals, including the AK, T, and NF-kappa, B pathways, temporarily shielding cells from undergoing programmed cell death. These core defense responses enable us not only to survive under stress, but also to enhance the body's resilience. In addition to these core defense responses, cells employ a sophisticated protective mechanism under stress. First is protein quality control UPR. When misfolded proteins accumulate in the endoplasmic reticulum, cells reduce protein synthesis and increase molecular chaperones to facilitate correct protein folding. Then, the DNA injury response DDR. Cells activate repair mechanisms and pause the cell cycle to prevent erroneous DNA replication. The third is the heat shock response HSR. Under high temperatures or other stresses, cells produce heat shock proteins that stabilize cellular structures, prevent protein aggregation, and promote survival. There is also stress granule formation. During acute stress, cells pause the translation of certain mRNA molecules, temporarily storing them and resuming synthesis after stress subsides. The fifth is the mitochondrial stress response MTUPR. When mitochondrial proteins are damaged, cells initiate repair processes to maintain stable energy metabolism. Finally, there is the cell cycle checkpoint. Stress activates checkpoint proteins such as P53, which pause cell division to prevent the transmission of damaged DNA. These defense mechanisms work together to enable cells not only to survive stress, but also to maintain stability and health. When we encounter stress, the body activates its defense system. The heart rate accelerates, immunity is enhanced, antioxidant enzymes are triggered, and cellular autophagy, the process of clearing damaged proteins, is initiated. This is called hormetic stress, moderate, short-term stress that is beneficial to health. Why is it beneficial? First, it can activate defense mechanisms. Mild stress trains cells to be more resilient through processes like autophagy, antioxidant responses, anti-inflammatory effects, DNA repair, and the production of heat shock proteins. Secondly, it can enhance immune function. Short-term stress increases the activity of natural killer cells, thereby strengthening immune surveillance. Thirdly, it can promote metabolic health. Intermittent fasting, exercise, and cold/heat exposure are examples of hormetic stress that improve insulin sensitivity and boost energy utilization. Finally, it can also delay aging. Research shows that moderate stress activates longevity genes such as sirtuins and AMPK, enhancing cellular repair capacity. Therefore, moderate stress is not harmful. Rather, it serves as a secret weapon for maintaining health and delaying aging. The mechanisms of the RIC Sphygmomanometer. RIC is actually a form of mild, short-term stress training. Research shows that this hormetic stress can activate the body's defense mechanisms, providing protective effects. The procedure is very simple. Using an RIC blood pressure monitor, inflate the arm cuff to 200 millimeters of mercury to temporarily block blood flow for 3 minutes, then release it. This process is called transient ischemia followed by reperfusion. It induces a systemic protective response through mild stress stimulation, providing protection to organs such as the heart, brain, and kidneys. In simple terms, the RIC Sphygmomanometer functions as a daily wellness tool, using brief periods of stress to strengthen the body's resilience, helping us resist disease and aging. RIC can initiate a series of defensive mechanisms within the body. First, it enhances antioxidant and anti-inflammatory capabilities, reducing damage caused by free radicals and modulating immune responses. Secondly, RIC activates cellular protective signaling pathways such as P-I3, K/AKT, nitric oxide, and heat shock proteins, which help cells survive more effectively. In the heart and brain, studies show that RIC can reduce the extent of myocardial infarction, decrease cerebral infarction volume, and promote functional recovery. More importantly, it has systemic effects. It not only provides local benefits, but also transmits protective signals to distant organs through circulating factors and exosomes. In summary, RIC represents a form of mild, transient hormetic stress. It can induce antioxidant, anti-inflammatory, autophagy, and cellular protective responses, enhancing the body's health and resilience. Research has confirmed that RIC induces multiple cardioprotective factors and pathways, creating a systemic defense network. First is nitric oxide, NO. It can dilate blood vessels, inhibit platelet aggregation, and reduce reperfusion injury. Next is SDF1 alpha stromal-derived factor, which mobilizes stem cells and initiates myocardial repair signaling. MIR144 microRNA regulates translation, helping cells resist apoptosis and adapt metabolism. Within the myocardium, LDH2, SGRT3, and HIF1 alpha pathways reduce the lipid peroxidation product 4, HNE, and regulate autophagy, thereby enhancing antioxidant capacity. At the same time, heat shock protein HSP stabilizes protein structure, reducing misfolding and aggregation. Exosomes and plasma factors act like messengers, transmitting protective signals to distant organs and activating survival pathways. In addition, neural signals rapidly initiate protective responses in the heart by stimulating peripheral nerves through applied pressure. Finally, antioxidant and anti-inflammatory enzyme networks, such as S, O, D, and catalase, neutralize free radicals and suppress excessive inflammatory responses. These factors and pathways collectively form a defense system triggered by brief ischemia, which not only protects the heart from ischemia-reperfusion injury, but also demonstrates anti-inflammatory and protective effects in various surgical and tissue contexts. Heart conditioning, also known as remote ischemic conditioning, RIC, is a technique that strengthens the body through brief episodes of stress. The procedure is simple. A blood pressure cuff is inflated and deflated to create brief ischemia-reperfusion. This type of stimulation releases health-promoting factors such as nitric oxide, cytokines, and microRNA, while simultaneously eliminating harmful agents like free radicals and apoptotic cells. As a result, the extracellular fluid environment improves, mitochondrial function is enhanced, autophagy, the process of cellular self-cleaning, is promoted, myocardial cells are protected, and cardiac reverse remodeling occurs, ultimately reversing disease and aging. This concept closely resembles that of heterochronic parabiosis. Young blood supplies anti-aging proteins, whereas aged blood contains factors that accelerate deterioration. The commonality between the two is the regulation of extracellular fluid, which increases protective factors and removes harmful factors, thereby rejuvenating tissues. The difference is that heterochronic parabiosis involves the exchange of external blood, whereas heart conditioning induces protective factors internally. Therefore, heart conditioning can be described as a self-derived form of heterochronic parabiosis. Similar anti-aging effects can be achieved by improving extracellular fluid without the need for young blood transfusion. Clinical research shows that RIC not only reduces the size of myocardial infarction, but also improves cardiac function in patients with heart failure, with evidence of cardiac reverse remodeling. That is, the heart becomes smaller and functions better. Even more remarkably, it protects organs such as the brain, kidneys, and lungs, demonstrating a systemic anti-aging effect. Recent clinical research has increasingly recognized RIC as part of healthy medicine rather than merely an adjunct to traditional therapies. The latest clinical trends are even more promising. In the field of brain hemorrhage and stroke, the multi-center RIC-H2 study in China has demonstrated that remote ischemic conditioning, RIC, can accelerate hematoma absorption and improve functional outcomes, providing a non-pharmacological and non-surgical health strategy. In acute ischemic stroke, the first affiliated hospital of Zhejiang University is conducting the RICLA randomized controlled trial to explore the therapeutic effects of RIC on patients with large artery atherosclerosis, emphasizing its potential in health medicine. In the field of cardiovascular disease, RIC has been shown to reduce myocardial injury and improve prognosis during cardiac catheterization and coronary artery bypass graft surgery. More importantly, long-term daily application of RIC can improve cardiac function in patients with heart failure, with observed reverse ventricular remodeling, considered evidence of disease reversal. Finally, RIC also demonstrates the capacity for multi-organ protection. Its benefits extend beyond the heart to reducing kidney injury, promoting neural repair in the brain, and improving vascular function, highlighting its systemic, cross-organ health effects. In summary, RIC is no longer just an adjunctive therapy, but a healthy medicine strategy capable of reversing disease and aging. Traditional medicine primarily focuses on treating diseases, often through interventions at the organ level. Healthy medicine takes this a step further. It emphasizes improving extracellular fluid and releasing health-promoting factors, which not only treat but also prevent, delay, and even reverse disease and aging. The role of RIC is precisely here. It is a simple, non-invasive method that can be performed daily at home, becoming a routine health strategy like diet and exercise rather than merely an adjunctive therapy involving surgery or medication. Clinical research has confirmed that RIC promotes reverse remodeling in multiple organs such as the heart, brain, and kidneys, improving function and demonstrating anti-aging potential. Therefore, RIC has progressed from a traditional adjunctive therapy to the level of healthy medicine, becoming a health strategy capable of reversing disease and aging. Therefore, RIC is not just an adjunct to conventional therapy. It is also a form of healthy medicine. It closely aligns with the philosophy of Zhang Zhongjing from the Eastern Han Dynasty, overall body protection and longevity through nurturing life. This ancient modern connection shares the same goal, extending lifespan and reversing aging. 2,000 years ago, the renowned physician Zhang Zhongjing of the Eastern Han Dynasty proposed the concept of overall body protection and longevity through nurturing life. He believed that medicine should not only treat diseases but also promote wellness and longevity by harmonizing qi, blood, yin, and yang to maintain internal environmental stability. In modern times, RIC perfectly reflects this same principle. It not only reduces myocardial injury and improves cardiac function, but also promotes cardiac reverse remodeling, thereby reversing disease and aging. Ancient methods included medicine, diet, guided exercises, and acupuncture. Modern methods involve brief ischemia and reperfusion using a blood pressure cuff, which is simple and non-invasive. The outcome remains consistent, extending lifespan, slowing aging, and preserving vitality. Therefore, we can say that Zhang Zhongjing's way of health preservation and RIC's healthy medicine are essentially parallel. Despite differences between past and present approaches, one balances yin-yang and vital energy and blood, while the other improves the extracellular fluid. Both aim to provide overall body protection and longevity to sustain life. In summary, RIC's mechanisms of health preservation can be divided into three key aspects. 1. RIC is a form of mild, short-term stress training. This hormetic stress activates the body's defense mechanisms, delivering overall protection. 2. RIC closely resembles the concept of heterochronic parabiosis. Young blood can bring rejuvenation through transfusion, whereas RIC triggers protective factors and removes harmful agents through an autologous mechanism. Therefore, RIC is considered an autologous anti-aging strategy that can mimic the rejuvenating effects of parabiosis in the heart and other organs. 3. RIC effectively promotes heart reverse remodeling, leading to ventricular size restoration and functional improvement, demonstrating the potential to reverse disease and aging. Does everyone believe that RIC can promote health? Hurry and purchase a healthy RIC Sphygmomanometer. Improve your health every day. Remember to scan the QR code below. RIC has 3 major health-promoting mechanisms. 1. Mild, short-term stress training. 2. Simulating the rejuvenating effects of parabiosis. 3. Cardiac reverse remodeling. Does everyone believe that RIC can promote health? Hurry and purchase a healthy RIC Sphygmomanometer. Improve your health every day. Remember to scan the QR code. Thank you all for watching. I am Dr. Andrew Shu Lee. See you next time.